Alright, so you're welcome to my video, and I'm going to be taking you through today on how we can derive quadratic formula using completing the square. Alright, so stay tuned, ask your questions through the comment section. Let's begin this journey. Alright, so for a quadratic formula of the form ax squared plus bx plus c equals to 0 for a quadratic expression or equation rather of this form, where a, b, and c are constants. All right, so it's quite simple to derive the quadratic formula from here. All right, so it will make sense when we get to the quadratic formula. So if you look at this, you can see that in this equation, all right, a is the coefficient of x squared, b is the coefficient of x, and c it's a constant, so it stands alone. All right, so the first thing we're going to do is that we are going to divide each of these terms by the coefficient of a squared, of x squared rather, the coefficient of x squared. So the coefficient of x squared is obviously a. So we begin, we divide the first term by a, divide the second term by a, divide the third term by a, and of course divide 0 by a. So this expression now becomes, you can see, this will become x squared plus bx all over a plus c over a. Of course, you see here that 0 divided by a is going to give you 0. So the next step is also quite simple. You can see that we have reduced the coefficient of x squared to just 1. So the next thing now we're going to do is that we are going to collect like terms. What I mean by like terms here, the terms with x, be it x squared or x raised by 1, is going to be on one side, and the terms without x is going to be on the other side. So we move. So this will become x squared plus bx all over a. Of course, you see this does not contain x, so we're going to take it to the right hand side. So this will be equals to 0 minus c all over a. Of course, you can see that 0 minus c all over a is going to give you minus c all over a, minus c all over a. All right, so I just put that up so you can understand. All right, so the next thing we are going to do here is quite simple. We are going to consider the coefficient of x, all right, and what we're going to do to the coefficient of x, and the coefficient of x is b all over a. That's the coefficient of x. So we'll look at the coefficient of x, and we will multiply the coefficient of x by 1 over 2, we'll multiply by half, and then we're going to square the result. Or we will divide the coefficient of x by 2. Now, listen, dividing the coefficient of x by 2 and then squaring the result is the same thing as multiplying the coefficient of x by 1 over 2 and then squaring the result. Multiply the coefficient of x, which is b over a, by half, and then we square the result. Why are we doing this? We are doing this so that we can complete this square, so that we can make the left hand side a perfect square. So why I'm doing this is I'm taking a route to making the left hand side a perfect square. All right, so after I have done this, the result is going to be b times 1 is going to be b, well, a times 2 is going to be 2a all square. Now we could have simply open these brackets, and then what we're going to have is going to be b squared all over 4a squared. But before we open this bracket, we are going to add this result to both sides. It is in adding this result to both sides that makes the left hand side a perfect a square, that we have successfully completed the square. So in other words, b all over 2a all square is the term which we need to add to x squared plus bx all over a to make the expression on the left hand side a perfect square. So that is what we mean by completing the square. So we're going to add this term to both sides before we open this bracket. So this will now become x squared plus bx all over a plus b all over 2a all square equals to, all right, this is minus c all over a plus b all over 2a all square. So from this point, you can see that the left hand side has now become a perfect square by adding that result. So the next thing we move ahead to do is that we are going to expand. We're going to open that bracket. This bracket we see here, we're going to open it on this other side. We'll open this bracket, and when we open this bracket on the right hand side, that's what I mean. That will become x squared plus bx all over a plus b all over 2a all square equals to minus c all over a plus b square all over 4a square. How did I get b square over 4a square? If you open that bracket, square b, that'll give you b square. Square 2, that'll give you 4 square a, and that's going to be a square. All right. So we are making much progress. So at this point, to continue this, I may go over cleaning. You can just all right. So if you look at here, you can see that when you add b all over 2a all square to both sides, this is going to be what it's going to become. So this minus c all over a plus b square all over 2a. Now I want you to know that if we have something like minus if you have something like minus 2 plus 5, for instance, minus 2 plus 5 is the same thing as plus 5 minus 2. Now there's a reason why I am showing you this, because this becomes 5 minus 2. Of course, it's not necessary to put that plus sign behind the 5. So minus 2 plus 5 is the same as 5 minus 2. So that's why minus c all over a plus b square all over 4a square is the same thing as b square all over 4a square minus c over a. I believe you got that. So the next thing we're going to do is we are going to factorize the left hand side. All right, using this to complete the square means that we have successfully made the left hand side a perfect square, and factorizing a perfect square is quite simple. All right, so how do I factorize the perfect square? Because in this expression, x squared bx all over a and b all over 2a all square, this term was gotten from this term. So when factorizing a perfect square, what we just do is pick this term x, pick the term inside the bracket, which is b squared, all right, plus b all over 2a. All right, I'm saying plus because the coefficient, the sign before b here is positive. There are times when you're going to be using numbers, this sign is negative, so it has to be minus. So I'm just emphasizing why we are putting this plus here. This plus sign is not this plus. This plus sign is not this plus, but it is the plus that is inside this, is the sign that is inside this bracket. All right. So we proceed, and then you square it. So this is how to factorize a perfect square. And in the right hand side, what we're going to do in the right hand side is that we are going to simplify this. We're going to add this and simplify this. All right, we'll simplify this. So how are we going to do that? Algebraically, the denominators are 4a square and a. So what is the LCM of 4a square and a? The LCM of 4a square and a is simply 4a square. So what next thing to do is 4a square divided by 4a square is 1. All right, is 1. So after that, 1 times b square, that's going to give you b square. All right, so 4a square divided by, of course, we bring in a minus sign. All right, 4a square divided by a of course, that's going to give you 4a. 4a times c, that will give you 4 ac. So we have successfully we've further simplified the right hand side. All right. So the next thing we're going to do is we are going to take the square root of both sides so that we can remove this square that has put these two terms in bracket. So doing that, taking the square root of both sides, all right, let me write this well so that it doesn't bring some confusion. All right, take the square root of both sides. So this is going to become square root of, and I'll take the square root. All right, so you can see that if I'm taking the square root of a squared expression, the square cancels the square root. So what I have left here is simply x plus b all over 2a. And then what I have here, now I want you to know something. It's important to note that if I take the square root of an expression, the answer could be a positive or a negative answer. For example, if I say, just look at this. If I say that x squared is equals to 4, and then I want to find x, so I'm going to take the square root of both sides. All right. So this is going to be x is equals to plus or minus square root of 4, which is something I'm saying plus or minus 2. This is true and profound because if you put positive 2 in place of x squared equals to 4. If you put positive 2 in place of x, is going to give you 4. Or if you put negative 2 in place of x and then you square it, negative 2 all square is still going to give you 4. So taking the square root of an expression can give you a positive or a negative answer. So that is why it is important that we include a positive or negative sign there. Yes. So I believe saying this and saying that will make it clear. All right, so we proceed. This becomes plus or minus square root of b squared minus 4 ac all over 4a squared, all over 4a squared. But we could have just jump over this step, all right, by introducing something. All right, watch this. So I was saying that this expression can be more expressively written this way. What do I mean by that? All right, these square roots cover the numerator and the denominator. It can be separated to look like this. So this is square root of b squared minus 4ac divided by square root of 4a squared. All right. So it is not easy to simplify this numerator, but it's easy to simplify the denominator. All right. So square root of 4 will give you 2, and square root of a squared again going to give you a. All right. So we're going to put that immediately as we proceed. So this is going to be remember. All right. Plus or minus. Thank you. All right. So from here you can see that we are very close to our answer. So we are going to make x the simple formula by taking plus b all over 2a to the right hand side, and this will become b equals x is equals to, this crosses and becomes minus b all over 2a plus or minus square root of b squared minus 4 ac all over 2a, all over 2a. All right. So look at this. So from here you can see that these two terms have like denominators. All right. So from here we can because they have like denominator, so we can just express it with the common denominator, because if you find the LCM and simplify this, they will share the same denominator. So what I mean is this will become x equals to minus b plus or minus square root of b square minus 4ac all over all over 2a. So at this point we have successfully gotten to where we can say that this is the quadratic formula. But I'm going to show you something before I bring this video to an end.
Don't say anything yet. You just allow time to be going small.
All right. So we've gotten to the end of this derivation, but what I want to show you here is, you can see the quadratic formula, that minus b plus or minus square root of b squared minus 4ac all over 2a. All right. Now this formula is very useful if you were asked to find the roots of a quadratic equation. This is called the quadratic formula. All right. And you can see that this is can be practically used when, of course, a quadratic equation is such in which you are required to find two roots. When you plot a quadratic graph, roots of a quadratic equation are the 2 points where the quadratic curve cuts the x-axis. So those 2 points, first point called x1, that's the first root, the first point, can be given as, because this is plus or minus, so you just to use the plus sign and evaluate this with the values that you are being given. And the second root is, instead of using plus, you use the minus. So this is how we can use this equation to find the root of a quadratic equation. In my next video, we're going to look at practical examples, not just on how we can use this formula, but how we can go all the way via completing the square. So thank you very much for being part of this class. You can share this video, you can like and subscribe. Alright, so you can like, you can subscribe, and you can hit the notification bell so that you will be notified whenever I release new videos. Don't forget, learn with master. Alright, so you can share this on all your social media handles, and see you in my next class.